Yeah, so our last, but certainly not our least, track is on sustainability. And personally, I'm very excited about the opportunity to bring the scale of this group and, the efforts of the applications and the talks we're about to hear to this problem. In almost by definition, this is the kind of problem that lends itself well to tinyML. When we're talking about sustainability, and the sheer size of the global problem of how to address climate change and impact really requires the kind of scalability that tinyML can bring, where you can only impact what you can measure, and you can only measure through a technology that allows you to take tens of thousands to millions of sensors and really get a good understanding for everything from natural resource preservation to impact mitigation for climate change to energy conservation. This past year, SensiML, in partnership with Hackster.io, had sponsored a climate challenge contest to elicit tinyML applications specifically that could help impact climate change. And we saw just a ton of different of great ideas come in. And when the tinyML for Good working group was formed, it was very gratifying to see that we could take this now to sort of a broader level and have the contributions of the community at large look at this problem. So with that, I guess I'd like to introduce the first of our talks. We have Keenan Johnson, who is the founder of Ribbit Network, who's going to talk about his network of open source, low cost carbon dioxide gas sensors. So Keenan, I'll turn it over to you.
Hello, and thanks very much for the introduction, Chris. Hi, everyone. I'm Keenan. I'm here in Seattle, Washington, the United States, and I want to talk to you about Ribbit Network, which is sort of the culmination of my work in climate. I've had the opportunity to work in climate for a good few years now. I've worked in a bunch of different kinds of startups for climate, and I'm really excited about this particular problem. So, Chris, I don't know if we can advance to the slide here, and we can really get into it. But so just to set the stage for climate change, for those of you who don't know, I'm sure you're aware of it, we know exactly what's causing climate change. We are producing greenhouse gases at an incredible level. Like if you look at the graphs of greenhouse gas production, you see like a massive uptick in the last 10 or 15 years, and it's growing exponentially. That is the cause of climate change, full stop. I guess if you're like me, it would probably have been reasonable to assume that we have like a really good map of exactly where carbon emissions come from, where these greenhouse gases, like what is producing them. We can have like a sci-fi view where you pull up a map and click and see in real time for a major city where are these gases, like what's producing them, so we can go be like investigating solutions. Unfortunately, that's just not the case. We don't have that map for climate change today. The information that our corporations and our government leaders use to create policy change comes mostly from like estimates created by hand. So they say like, oh, okay, well, like we know what the power load was in the city at this time, and we kind of estimate what the greenhouse gas emissions from this power plant are per kilowatt hour. So we think the emissions are this, which is crazy. Like as like a data person and a scientist, and I think everybody on this call could agree, like we have the technology to go deploy these sensors very widely. And so that's the problem domain that I've become sort of obsessed with. And I founded Ribbit Network to go tackle, which is to build that missing map of climate emissions using tiny IoT sensors. They're super low cost. They're easy to deploy. Citizen scientists can put these things out in their house. Corporations can use them and deploy them at their facilities. And our government leaders can take this data set and use that to make good climate policy impact stories, which is, what we're all here for. So that's what we've done. So we've built a tiny open source sensor. We call it a frog sensor. In keeping with the Ribbit Network theme, we call it the Ribbit Network because frogs are a good indicator species for climate change. They're hypersensitive to temperature, which means that they're some of the first species affected by climate change. And they also, just like our IoT devices, communicate to each other in this massive distributed network through their ribbits. So it's a very fitting name. We've been working on this for a few months, and I'm proud to announce that we've had great success. You can check out what we're doing at ribbitnetwork.org. You can also check out the links to our GitHub that are on there. You can join a Discord. We are, everything's in the open source, which I think is really cool and really important. We're just sort of, we've been really focused on the hardware, and we've been super fortunate. We've just deployed our alpha test fleet of our sensors. So we have 25 sensors just about in 5 countries all over the world. And we're getting ready to roll out our beta set of sensors. And we're sort of just at the start of like, what is the possibility for software on these sensors? And that's where I'm really excited about things like tinyML, because this is a very distributed, like grassroots kind of organization, which very much fits into the ethos of tinyML, which it's like, how are we going to solve climate change? It's probably not by like picking one solution and that we all do. It's going to be, hundreds and thousands of tiny little solutions all working on their own that collectively make up the problem answer. And that's the same as tinyML. So I'm really excited. So we could really use some help figuring out like how to get tinyML into these sensing devices. We've got a ton of problems, for example, in determining sensor health, sensor calibrations, using tinyML to pinpoint sources of emissions combined with our wind data, which we're just doing the very beginning of. There's a ton of exciting problems to do in ML. So I would love for anybody who's interested to come join us, like come find us on Discord, send me an email. I'll put my email in the chat here, but get in touch and let's build this missing map for climate together. So thanks very much.
Great. Thank you very much, Keenan. That's very enlightening, and I appreciate your talk. I think like you, it's easy, and I even kind of assume that that most fundamental of information is available with satellite imagery, and the data was plentiful. So it's interesting to hear that isn't the case, and that networks like yours can really help fill in a missing gap there. So thank you. Next we have Doug Stanley, who's founder and CEO of Niolabs, who's going to talk about groundwater wells and the untapped edge use case. So Doug, I'll turn it over to you.
Thank you, Chris. I want to thank all of today's event organizers. I think it's a very special and important event. I also want to particularly thank Olga for organizing all of us cats and pulling this event off. It's a Herculean effort. And lastly, I appreciate Kate, our keynote speaker, for sharing Ibrahim's Azerbaijan story on precision ag, because it's incredibly complementary to what I'm going to talk about today. So I'm going to start by taking you on a little bit of a journey and telling you a story. Right now, it's a super quick story. And then after this 5 minutes, I'm going to have one thing I want you guys to do for me. I want you to think today as you're drinking, as you're flushing, perhaps as you're watering your yard, or gazing at a lake or a stream. I want you just to think about water, just a little bit more than you normally do today, okay? So that's my one ask of you today. So 6 years ago, we had the good fortune of taking our ideas and our invention into a factory and connecting that factory, leveraging our software and doing live enterprise user testing. And as we were doing the factory, it quickly became widely known to us that a factory is a very controlled, somewhat predictable environment. So we asked ourselves, what is harder than a factory? And so we quickly determined that what was harder than a factory was a farm. And if you could switch to the next slide, please. So being the way we are, being inquisitive, we decided to go off and connect a farm. And in this farm, we massively digitized this farm, taking advantage of our software advancements as well as distributed edge computing architecture. Now, this farm is located in Wilcox, Arizona. If you could advance the slide, please. So Wilcox, Arizona is about 50 miles from the Mexican border, incredibly remote. In fact, in Wilcox, there was zero network, not even a DSL line. We got our wish. We increased the challenge dramatically. Before I leave this slide, I want you just to look across from where it says Asmundson Family Farm, from that red dot. Look across at that piece of land. I'm going to refer to that again in just a little moment. Next slide, please. So once we connected the farm and we shared it with the world, farmers and scientists, particularly those in academia, started asking us, oh, well, what about results? Well, at the time, once we connected the farm, we didn't know. We didn't know what the results would be at all. So frankly, a couple of years later, after a couple of harvests, we organized the results and we presented it at Google Next on stage inside the IMAX theater, just the actual results. And the results from this, frankly, are the holy grail of precision ag. We saved about 75% of the water, 40% of labor, 20% of energy, and improved quality, as well as increasing yield. So we lowered the cost of operating the farm dramatically, and we increased the results dramatically, which again is somewhat the holy grail of farming. Today, I'm going to talk to you about, on the next slide, as we move to Gen 2. So here's the problem. It's pretty widely understood, those of you that have been around precision agriculture, that farming is one of the largest users of fresh water in the world. It's also, regrettably, one of the largest wasters of water. It's incredibly inefficient. Shockingly, farms and farm water usage specifically is generally unmonitored and unregulated. So today I'm going to hone in specific to groundwater wells, which is about 50% of the source of agriculture's water. In the world, there are 39 million of these wells, and recent research out of UC Santa Barbara shockingly told us that upwards, close to 20% of those wells are going dry. Now, in Arizona alone, we have about 250,000 groundwater wells for commercial use statewide, most of which are not connected, all of which are unregulated. In Arizona, if you need a well, you just dig a hole. So here's the impact. We're talking about loss of 10% of the world's fresh water. I want you to think about that today as I ask you to consider water more closely. And once a well or an aquifer goes dry, there's literally nothing else you can do, no source of water. Occasionally, there's the ability to dig a deeper hole. The result of that is massive food production loss, which impacts nutritional quality, loss of available drinking water, and of course, significant economic loss. So in essence, a huge flywheel effect in broad sustainability matters were just related to water and agriculture and specific groundwater wells. So what we want to do is we want to take these results that we've demonstrated in these past 5 years, and frankly, as some of the tinyML organizers know, somewhat worldwide acknowledgement and acclaim for this test farm, what started as a software test. We want to take it to Gen 2. And Gen 2 is a complete reimagination of what we can do at a farm, complete re-architecture. And we're looking for the tinyML community to participate. Yes, we've got ML at the farm, but we didn't know what we didn't know back then. And we think there's lots of opportunities to advance these highly censored environment and really leverage ML far beyond what we're currently doing. So here's my call to action for even one of you that are out there that want to help on this and help us push ML further to the edge. We will need to complete this by March 22 of 2022. Why? Because that's when the growing season starts. And one of the big challenges we have in farming is you do not modify a farm during a growing season generally. So we'll be out of the dormant period going into the first quarter, and we'll be live with a new architecture by March 2022. Our goal here this year is to create a repeatable solution that can be transferred to other farms, including farms in Azerbaijan. And specifically, we want to create a well solution for those 38 to 39 million wells that are going dry. that could be replicated and deployed to create monitoring. And we believe that that can be done for less than a Netflix membership on a monthly basis. To do that, we're transitioning our efforts from our corporate for-profit as it relates to this farm and putting it into a not-for-profit model. So we'll be arm in arm with organizations like tinyML doing this arm in arm. Now, let me tell you the story back to that land across the street. So last year, in one of the most highly automated farms in the world, we ran out of water. We ran a well dry. And we ran a well dry with no doing of our own. Across the street, they had sold the land to a giant milk farm, and they started growing grazing grass. And of course, all of the water associated with grazing grass is demonstrably higher than we were using. We use less than an acre foot to grow these fine wine grapes. So across the street, they stuck a bigger straw into the aquifer than we had and started sucking more water. It's called overdraft. And so wells are not just about your only usage. Lesson learned, as efficient as we can be at that farm, it means nothing if our surrounding neighbors or our system that's tapping the aquifer does not also play nice and has low awareness to sustainability. So that really is the genesis of us wanting to focus on groundwater wells. There has to be a solution and there has to be regulation, but the solution has to be incredibly efficient and low cost. Again, the call to action today to the tinyML committee. So next slide, please. You can, there's our website. This is a case study on our website, niolabs.com. And then I'll post some other things in the chat. And thank you very much for the time today. Appreciate it.
Great. Thank you very much, Doug. That's a great example, very encouraging use case based on the results that you had. And what a pilot project. If you can do this in Southern Arizona, then you can do it a lot of places, I imagine. So thank you very much for that. Next, we have Emasi Collins, who is a researcher at the Center for Data Science and AI in Kenya, the Dedan Kimathi technology. And he's going to present on acoustic monitoring of ecosystems. Emasi, I'll turn it over to you.
So, my name is Collins Emasi, an undergraduate research assistant at DSEL, and I've worked on this project with Gabriel Ciira, who is a researcher at DSEL with counsel from Dr. Ciira, MAINA, our director. Now, on to the next slide. In the next slide, you will see that there is an increased degradation of ecosystems due to human expansion and climate change, and therefore there is a need to increase conservation efforts to preserve biodiversity. And traditionally, wildlife was monitored by carrying out periodic physical surveys. This method is inefficient since it is laborious, expensive, and time-consuming. Now, this will make it hard to carry out physical surveys in our ecosystem frequently. And acoustic data is one form of data that we can collect and use to study the trends in our parks, reserves, and conservancies. Now, on to the next slide, you will see that this project falls under environmental conservation, and the environment contains a lot of acoustic data that tells a lot about what is happening around. Animals produce sounds that enable us to identify them without the need to physically observe them. In our case, we will choose to use birds. And the reason is not just because birds are really cool creatures, but birds respond quickly to changes taking place in their habitats. And as you know, birds are very vocal creatures. Acoustic monitoring of ecosystem provides an inexpensive and non-invasive tool for collecting data and analyzing the state and changes taking place in the environment remotely and continuously, which is exactly what we are looking for. On to the next slide. So we have to build a system that will put into action all the jargon of what I've just mentioned. And at the Center for Data Science and Artificial Intelligence, we have developed the DSEL acoustic sensor, which is based on the Raspberry Pi. The system is powered by a solar panel and a battery, leveraging the ample sunshine in the tropics. Now, we have developed the sensor for data collection at the Dedan Kimathi University of Technology Conservancy, And the figures on the next slide will show you the sensor during its development and deployment. So you can see there that there is a power supply unit for the Raspberry Pi. This was developed by some of the great minds at DSAIL. You can also see the Raspberry Pi and how it looked out in the field. Also, I should mention the audio mode. It is an existing technology that is used to record sounds for acoustic monitoring of ecosystems. It can filter unwanted sounds, hence it can be used for acoustic events logging. Now, on to the next slide, I'll discuss about the Raspberry Pi Pico. So bird audio detection involves distinguishing bird sounds from non-bird sounds. Yeah? We trained a binary classification model and flashed it onto the Raspberry Pi Pico. And here tinyML helps us in sorting the several hundred hours of recording we have got from the DSAIL acoustic sensors. So you can see the setup there. We have the, we are using the Adafruit PDM MEMS microphone for now listening to the audios. On to the next slide. So we have a huge set of unclean and unlabeled data from the DSAIL acoustic sensor. And the plan is to use the bird audio detection algorithm to sort the recordings into bird sounds and non-bird sounds. From there, we will label the bird sounds data and use it to develop machine learning models and deploy them in the acoustic sensors for automatic acoustic classification of birds. And high quality microphones are also needed to collect high quality sounds. Now, the global tinyML community can help by providing us with hardware and high quality microphones to develop more acoustic sensors for deployment in our vast ecosystem. On to the next slide. I'd like to thank all of you for listening to this lightning talk. And I have had, and I think it is true that the future of ML is tiny. Thank you.
Thank you, Colin. That was a very interesting talk, and I guess there's a good reason they say canary in the coal mine, because birds can teach us a lot about the trends of what are happening and the impact of what's going on. And so this is a fascinating project that you're working on. Next, we have Clinton ODUOR, who's co-founder of Niolabs, who's going to talk about precision beekeeping and helping to address the problems that are well known in the collapse in honeybees. So Clinton, I'll turn it over to you.
So thank you. I hope you can hear me. So I'm Clinton and I lead the tinyML Kenya community. So at tinyML Kenya, we try to experiment how we can use tinyML to solve some of the challenges the community face today. So next slide. So today we're going to talk about like how tinyML can help save the bees and also help beekeepers make the most out of their beekeeping activity. So apparently every third bite of food we take today depends on bee pollination, but unfortunately we lose again 30% of bee colony annually. So this poses like a very big threat towards the progress that we already made towards SDGs such as zero hunger, because as of today, there's a lot of hand pollination practice being practiced all over the world. So again, traditional beekeeping based on traditional practices has become also like a hindrance to apiary profitability because of challenges such as hive haste. And this problem is really very big because like just from the ground, there is a day whereby more than 40 hives were lost in one night. Other challenges faced by the beekeepers is are things to do with conflicts between human and honey badger. Honey badger are usually pests, and they're usually pests that usually go to the beehives and eat all the honey. And it's usually recorded that every year, more than 14% of beehives are usually destructed in Kenya. So there are challenges also such as pest and disease infestation, which are usually due to poor microclimate environment of the beehives. Next slide. So to solve this problem, we came up with a solution called IBEES. So what IBEES does is that IBEES is an AI-powered beehive monitoring solution to help beekeepers monitor the health of their beehives in real time on their phone, and also to help the bees. So how IBees works is that it has sensors such as temperature, humidity, weight sensor, acoustic sensor, and also vibration sensors. So why these sensors? For example, things like humidity sensors can tell us when the hive is dumpy, which may lead to pest and disease infestation, fungi, and also mold growth. And weight sensor can help us keep track of the honey production and also bee colony population. Things like temperature sensors can also help us understand the brooding cycle of the bees. And vibration sensors can help us detect when a beehive has been knocked over or it's about to be stolen. So we are also experimenting on things to do with acoustics of the beehives, because the buzzes of the bees can really tell us a lot. So we are experimenting things to do with whether we can detect whether a queen is not laying, whether a queen is not laying eggs or not, or whether the colony is about to swarm, or when the bee are being disturbed, which may lead to rapid swarming of the bees. Next slide. Next slide. Okay, so these are just some of the pictures from our deployment. So what we do is that we don't just go and deploy our devices to beehives that already have bees for now. We try to monitor the whole chain, whereby we try to monitor when the beehives don't have like bees up to the time they are occupied by bees, so that we can understand these parameters that we're trying to monitor. So this phase also, we are really collecting like a lot of data that can also help us like train our machine learning model that we can deploy on the devices. So regarding the acoustic monitoring of the beehives that I just talked about, we recently tried on using like data that's already available, but it couldn't work well. That's why we also decided to dedicate more time to collect more data that can be used to train our machine learning models going forward. So next slide. So we are currently working with 10 bee farms and also bee experts, so that we improve on the device to make sense on the beekeepers, and also try to make sense from the data that we are collecting from the beehives, because we are technologists, and the bee experts and bee conservation experts are the only one who can help us understand some of the things that we're trying to solve. So we are also doing a redesign of the device to make it like a custom device that can easily fit in a beehive at a very low cost. And we are also looking for partners to help us unlock more possibilities on IB's radical approach on bee conservation and also impact to beekeeping. So by that we mean like we are looking for partnership in terms of bee conservation experts, technical partners for hardware and cloud support, and also sponsorship in terms of grants. Thank you.
Great, thank you very much, Clinton. It's a great application, obviously a big impact with preserving key pollinators, and a great tinyML application given the connectivity challenges in the environments that this needs to operate in, combined with the rich sensing. So it's a great application. So next we have Barke ODUOR from the State University of Zanzibar to talk about the multi-sensor fishery device.
Hi everyone, my name is Barke. I'm sorry, my laptop camera doesn't function. My name is Barke ABDALLAH from the State University of Zanzibar. I will present multi-sensor fishery device. Next slide, please. Here in Zanzibar, Blue Economic focus on the sustainable of ocean for social economic development. Also, Zanzibar fishing sector is the sector that employ over 60% of Zanzibarians who live near the coast. Next slide, please. but they face a lot of challenges that hinder their daily fishing activity, such as they don't know where about to fish, I mean potential fishing grounds. Also, fishermen in Zanzibar use traditional gear, so the accidents in here are common. So when encounter those accidents, their safety are unsure. Due to the old problem that face fishermen in Zanzibar, I'm high concerned and motivated to introduce multi-sensor fishery device that aims to solve this problem. Next slide, please. How this multi-sensor device will solve or will be best solution to the fisherman problem. First, this device will embedded in fishing boats, so it enables him to detect or to know where potential fishing area, detect the size of fish, serve the surface. Their service are guaranteed. When encounter an accident while fishing, it will send an SMS to rescue center to give them alerts, and also it sends that data to the database. So the fishermen sector and government of Zanzibar, it's enabling to making better decision in order to improve fishermen sector in Zanzibar. Next slide, please. In order to overcome the challenge of fishermen, this device will have the following feature: fish finder, fish attraction, knowing fish size, fisherman surface, extraction of data. Next slide, please. Our project currently is in brainstorm and construction of idea. Next slide, please. And here is a sample of our device and how it will work. Next slide, please. This solution is expected to impact the fishermen sector in Zanzibar. Next slide, please. Due to the Zanzibar environment, there are some challenges will hinder the success of this project, such as, like I told before, these projects are in ideal stage. So the next step will need to develop multi-sensor fishery device. And in order to complete this device, we need radar, and sonar. Next slide, please. Due to the Zanzibarian environment, there are some challenges will hinder the success of the project, such as internet issue, acceptance of device, financial problem. So in order to solve those problems and to complete the development and uses of this device, we need capacity building, financial support. Thank you.
Great. Thank you, Barke. That's a great application and well thought through that you're appealing to the motivations of the different stakeholders, including the safety of the fishermen, as well as the need to collect data for the fisheries. So that's, thank you very much for that presentation. And then finally, we have a short video from Kate Williams. Kate is an amazing innovator at already a young age. She's having real impact and has a short video that highlights how kids can save animals. So I will we'll play this short video.
I'm spending my summer working with world-renowned experts, teaching my generation how we can save our most vulnerable species from extinction.
We'll be learning how pangolins rescued from traffickers are rehabilitated and released back into the wild.
We will be learning why we have to dehorn our rhinos to protect them from poachers.
And we'll be connecting with wildlife researchers to find out how collaring endangered species is helping protect them, learn more about them, and conserve them for future generations.
Come join us on this journey. Time is running out.
Chris, I just want to add that Kate is a dedicated person. She wanted to present it in person, but she's supposed to be at school right now. Unfortunately, we have a school conflict here, but she's been doing quite amazing work in this area and also in the community.
Great. And so with that concludes the section on sustainability.
As always, we'd like to thank our sponsors. Without this, it can't be done. So specifically our strategic partners, these are companies that have got involved in tinyML to help steer the direction and set the vision and drive the vision. And we'd love to see more strategic partners come along. We meet once a quarter where we can talk about some of these issues and technologies in a smaller group and come out of those meetings with specific calls to action. So if you'd like to get involved with the tinyML Foundation, and we'll give you more information. So the partners are Aeon Devices, ARM, DeepLight, Edge Impulse, EMSA, Greenwaves Technology, Gravity, HOTG, Imagimob, Latent AI, Maxim, who are now part of Analog Devices, Qualcomm, IXO, Reality AI, Renesas, Rexon, SAP, Seed, SensiML, Stream Analyze, SynSense, and Sentient. In terms of executive partners, we have various levels of partners and sponsorship. There's more information about this at tinyml.org. But we have ARM, who's been a great supporter since the beginning. Edge Impulse, who is a great solution for all tinyML developers. Qualcomm, again, one of the founding members of tinyML Foundation. And Sentient, and then our platinum partners, DeepLight, Reality AI, Renesas, and our gold partners, Latent AI, Maxim Integrated, now Analog Devices, Seed, SensiML, SynSense, and our silver partners, Aeon Devices, EMSA, HOTG, Greenwaves, Gravity, Imagimob, IXO, Rexon, SAP, Stream Analyze. So thank you. Once again, this has been a fantastic event. I've learned a lot and been inspired tremendously. I hope you have. And it's now about rolling our sleeves up and getting down to action and helping the people that have requested help this morning in some of their talks and showcasing some of their global initiatives that they're working on. I'm sure we can all come together and give a helping hand. And let's all get together and solve some of these global challenges. And if you need more information, just go to tinyml.org.